Section 2.2 is on direct variation. A direct variation function is one in which the ratio of the corresponding values is a constant. Its formula is y equals kx, or if you divide both sides by x, y over x is equal to k, where k is the constant of variation. Let's take a look at an example here. So for each function, determine whether y varies directly with x. If so, what is the constant of variation and what is the function rule? So for this first table here, I have 1 and 1 and 0.5, 2 and 1, 3 and 1.5. So if I were to, what I need to do is see, is y over x a constant value? So is 0.5 over 1 equal to 1 over 2 equal to 1.5 over 3, and indeed it is. In each case, the constant is, in this most simplest form, 1/2. So my constant of variation is 1/2, and yes, that's the way I make a k. I know it might look like an r, but it's cursive k. And the function rule is y equals 1/2 x. So in order to get the output of y, you have to multiply each x by 1/2. Let's take a look at number 2 here. Again, is y over x a constant? Is 10 over 1 equal to 22 over 2? And I'm going to stop right there because it is not, because 10 is not equal to 11. So no, this is not constant variation. Okay, y over x is not constant. So in other words, that ratio of y divided by x has to be the same for every set of ordered pairs. Here's another example. For each function, and it's given as an equation, determine whether y varies directly with x. If so, what is the constant of variation? In this case, I'm going to write each equation in the form y equals kx and see if it corresponds to that. So in this case here, what I would need to do is subtract 2 from each side, and that's going to give me the equation y equals x minus 4, and you'll notice that in our basic formula there is no, basically a y-intercept, there is no number added on the end. So this is not direct variation. Let's take a look at this one here. If I were to solve this for y by multiplying both sides by 6, I get y equals 6x, and yes, this is indeed, y does vary directly with x, and my constant of variation is 6. Here's another example that uses direct variation. Suppose y varies directly with x, and y equals -4 when x equals 25. What is x when y is 10? So, direct variation, y over x. So these numbers here are kind of ganged together. Y is -4 when x is 25. So -4 over 25. And then it asks me, what is x when y is 10? So when y is 10, what is x? And then we just solve that by cross multiplying. -4x is equal to 250, and x is equal to -62.5. You can also do this with word problems. Here's an example. The cost of buying fancy nuts varies directly with the weight. If 8.5 kilograms of nuts cost $47.60, how much do 20 kilograms cost? So I'm just going to set up a proportion. I'm going to do kilograms over cost. And if 8.5 kilograms cost $47.60, how much money, that's my x, do 20 kilograms cost? So I'm keeping my kilograms on top and my money on the bottom. Again, I'm just going to cross multiply. 8.5x is equal to 20 times 47.6, which is 952, or the cost of the nuts is $112. The graph of a direct variation function is a line that always goes through the origin. This is because the point 0, 0 is a point on every direct variation line. Think of it, if we have the formula y equals kx, no matter what k is, if x is 0, y is going to be 0. So let's graph a couple of these. So here we have the direct variation equation, y equals x over 5. So to do this, I'm just going to make a table of values. I'm going to pick a handful of x's here, but the x values I pick, notice that x is divided by 5, so I don't want to pick 8 because I don't want to have to graph 8 over 5. So I'm going to pick numbers that are multiples of 5. So I think I'll do -10, -5, 0, 5, and 10. Okay, so when x is -10, y is -2. When x is -5, y is -1. 0, 0 is always a point. When x is 5, y is 1. And when x is 10, y is 2. So let's just graph those points. So that's going to be -10, 2, -2, -5, 1, 2, 3, 4, 5, -1, 0, 0, 5, 1, and 10, 2. And that's not a super straight line, but you get the idea. So that's the graph of that direct variation equation. Let's try one more here. Here we have y equals -4x. Again, let's make a table of values. This time you'll notice that x is being multiplied by -4. There's no division, so it doesn't really matter. There's no real constraint on graphing nice values. So I'm just going to do -2, -1, 0, 1, and 2. So when x is -2, y is 8. When x is -1, y is 4. 0, 0. When x is 1, y is -4. And when x is 2, y is -8. So graphing that, -2, 8. It's right there. -1, 4. 0, 0. 1, -4. And 2, -8. So in this section, we took a look at direct variation, which uses the equation y equals kx, or y over x equals k, which is the constant of variation. We saw how to use that in some word problems and how to graph a direct variation equation.